Hola chicos, buenos días, bienvenidos al JConf Perú 2021. Vamos a iniciar el día de hoy con, con la sesión de Reza, que es, un segundito, que es Powering Java and Azure with Open Liberty and OpenShift. Reza Reza es Principal Program Manager para Java en Azure, en Azure de Microsoft. Él trabaja para asegurarse de que los desarrolladores en Java sean lo que se denomina First Class Citizens en Microsoft, en Microsoft como First Class Citizen del ecosistema en Java. Él ha sido oficial de las tecnologías de Java en Oracle. Es el autor del popular libro EJB3 en Action de Manning. Also, ha sido también un speaker frecuente de las comunidades de Java User Groups, conferencias a nivel de todo el mundo, como JavaOne and Devoxx. Has liderado Java EE, el track Java EE en JavaOne durante mucho tiempo, y bueno, le voy a dar el pase para que inicie con la presentación. So, Reza, we can start now.
Oh, perfect. All right, great to hear from everyone. So I'm going to go ahead and start sharing my screen, and then talk a little bit about the presentation and talk a little bit about what what we'll hopefully learn in about 45 minutes or so. So let me start sharing my screen. So here we go. You guys should be able to see my screen just about now. Okay, if you don't see my screen, do let me know. But I think it should be okay. All right, so let's talk about what our topic today is. So our topic today is about running Java, Jakarta EE, and microprofile applications on the Azure platform using Liberty as an implementation, and in particular targeting the OpenShift runtime. So this work is part of a broader partnership that we have actually with a number of companies in the Java ecosystem, but in this case in particular with regards to IBM. So we are working with IBM to enable essentially all of the WebSphere product family of implementations on Azure in as many ways that it actually makes sense. So this particular diagram represents a bit of that. Let me see if I can maximize the diagram a little bit more so you can see it a little bit more clearly. So here's the diagram that you can see. So basically what we're doing is enabling WebSphere Traditional. And the primary way we're enabling WebSphere Traditional is on Azure virtual machines. Similarly, we are enabling both WebSphere Liberty and Open Liberty, but we're not enabling that on virtual machines because we don't feel that that's the most effective platform for those particular runtimes. But we are enabling Liberty basically on both on Kubernetes as well as on OpenShift. So we have two different runtimes on Azure to do that. We have Azure Kubernetes Service for Kubernetes and Azure Red Hat OpenShift, which is actually developed in collaboration with Red Hat. It's a managed offering for OpenShift on Azure. And that is basically the other platform that we'll be talking about today that we're enabling Liberty on. Now, in addition to just basic enablement of the runtimes, we're also enabling different integrations with Azure. In fact, today I'll be showing you one of those integrations, in particular with Azure PostgreSQL. But similarly, we are enabling basically all kinds of database access, both either on-premise or on Azure. For example, a common scenario is running DB2 on-premise and running the WebSphere product family on Azure. Similarly, we're enabling integration with things like Azure Active Directory, as well as Elastic. We have a managed Elastic service on Azure, and this is not just limited to that. There's many different other kinds of services that you can use on Azure while you're running these Java EE application servers like Liberty on either virtual machines, Kubernetes, or OpenShift. So today we'll be talking about one aspect of this partnership. Namely, I'll be showing you how to run WebSphere Liberty and Open Liberty on Azure Red Hat OpenShift. That will be our focus today, and we'll see in particular how that looks like. So I do not have any slides for this presentation. Instead, I'll be just actually showing you what you need to learn in a more direct fashion. But what you can definitely do is all of the things that I'll be talking about is already out there. So one good starting point is this web page here. So if you type in something like Western Liberty on Azure, you'll land on this page. And it'll tell you a lot about what the partnership that we are doing and the different varieties of work that we are doing under that partnership. So as you can see here, Western Liberty and Open Liberty on ARO, Webster Application Server on VMs, as well as Open Liberty and Western Liberty on AKS. So we will be focusing today, as I said, on ARO. So there's a couple of different ways you can go about getting started with Western Liberty on ARO. One is sort of basic getting started guidance, and I'll show you that in a moment. It is linked from this page here, and that shows you a very basic steps, like every single step, like setting up your network, setting up an ARO cluster, setting up the OpenShift container registry. Everything is enabled and described in a step-by-step fashion. So first you create your OpenShift cluster, as you can see from this link number 8. Then you have to connect your Azure Data OpenShift with OC, the OC command locally, and then you have to enable the built-in container registry. There's step-by-step instructions on how to do that. You need to create an OpenShift namespace. You then need to set up an administrator using Azure Active Directory, and then you need to install the OpenShift operator and so on. And then after you do all of that, then you go ahead and deploy your application. So this is where we started initially, is we're writing this guidance, and this is jointly developed guidance that basically shows all of the best practices that we would want you to follow for doing Webster Liberty and Open Liberty deployments on Azure. But actually what we found was a lot of that instructions is relatively boilerplate. Right? So there's steps where you're really just doing nothing much more than running a script. There's no real possibility of you really modifying anything or installing anything or configuring anything. It's just kind of very repetitive steps. So instead, what we have done is, in order to simplify all of those steps, on Azure, we have created essentially a marketplace solution template. And I'll show you the marketplace solution template right here. So using the solution template, you basically will do all of that work essentially behind the scenes, behind a UI. So we have this concept called solution templates on Azure, and this is exactly what it does. So I'll show you how the solution template for Webster Liberty and Open Liberty on ARO looks like. By the way, we have similar solution templates for Webster on VMs as well as Liberty on AKS. So if I hit create here, you'll see several different options. So you'll see a subscription that you'll need to pick. Let me increase the font size a little bit here so you can see it a little bit more clearly. Maybe one more. Okay. So first you specify your resource group. A resource group is really nothing much more than sort of a grouping of different resources on Azure. You can think of it as an abstraction over a small data center. There's several resource groups that I've created already. I'll show you the one that I've created in a moment. You get to pick your region, and that's basically the Azure data center where you want this code to be running. In this case, I'm running it on US East, but you can pick whatever region that you want. You need to specify all of this is created through something called a managed identity. So you need to pick a managed identity as well. So I do have a managed identity that you can use to create these kind of things. But you need to pick one of those with the appropriate permissions. So it needs to be contributor in the subscription as well as application administrator in Azure AD. There's instructions on how to set this up as well. So there are all the instructions that you can follow to set all this up. Then you go ahead and configure your cluster. So you can either create a new cluster, so deploy a new instance of Azure Red Hat OpenShift, or if you have an existing Azure Red Hat OpenShift cluster, you can select that also. For example, I probably have one somewhere hanging around, but you can pick one. Other than that, you need to specify your Red Hat post secret. that is necessary for OpenShift deployment. You can get that from the Red Hat portal. I'll show you this real quick also. So if you click on here, I'll log on onto my OpenShift cluster, or rather my OpenShift account with Red Hat. And from here, you can get your post secret. So this is nothing much more than that Red Hat OpenShift post secret. We do set up a in OpenShift. It's called a project. So each application is hosted in a project. In Kubernetes terms, it's a namespace. So we set up a secure project for you through this template. So you do need to specify a password and name of an administrator. In this case, I've just named it for myself. And then you can specify a password to log on onto your OpenShift cluster. Next, you can configure an application. So you can deploy this without an application. It works perfectly fine. It'll just create an empty project for you. But you can also choose to deploy an application. So in that particular case, what you need to do is specify an application path. So you have to make sure that, for example, you have a image deployed in some kind of public repo, and you specify the full URL for the public repo here. And then we will go ahead and deploy that particular Docker image with the deployment. So this takes about half hour. We obviously that's going to take too much time for our application and for this presentation, which is just only a 45-minute presentation. So I've actually gone through this wizard already, and I have created the resources beforehand. So I'll show you the resources deployed. Okay, so these are the resources that are deployed for me. And if I go into Liberty Arrow demo group, which is where I have it created, you'll see there's two different things that are created on my behalf. One is a Azure Red Hat OpenShift cluster. So I basically have an Azure Red Hat OpenShift cluster now up and running. You can take a look at the activity log, and you'll see that I've created this beforehand. And there's also a virtual network where this is actually deployed. I've also deployed a PostgreSQL database. I can show you that in my other window, that there is a PostgreSQL database deployed in another resource group. So now basically I'm all set up and ready to go. All my OpenShift cluster has been deployed. A virtual network has been created for me. There's a secure project that was created, and of course, the Open Liberty operator, which is what we'll be using for this deployment, that is also actually deployed with the application as well. So I'll show you all of that in a moment also. So that is also part of what our deployment is. Let me show you real quick the data source that I've also deployed for us. Okay, so this is the data source that I've deployed. It's a PostgreSQL data source. There should be some activity here. Yeah, as you can see, there's some activity here. But basically, I have a database up and running that I can connect to. So next, let me show you the Red Hat OpenShift deployment that was actually done on my behalf. So if I go back over here and I look at the underlying resource group, let's do that. If I look at the underlying resource group for Liberty, and I go to deployments, this is all of the work. This represents all of the work that basically the template has done on our behalf. So as you can see, it took 45 minutes when I actually initially deployed this. So I can go ahead and take a look at that deployment. And if I go into the outputs, or actually even if I go to the inputs, you will see that there is a lot of work that was done on my behalf. But in the end, I get this output. So what I can do is there's several useful things that are in this output. One of the most useful things is actually where the cluster, the OpenShift cluster is actually deployed. So I can go ahead and log on onto the OpenShift console using some of these outputs. So let me copy this, and you'll see other useful things like the OpenShift container registry that was created for us. There's a name for that, the actual generated project names. That is the project name. And so on. So there's a number of useful bits of information that is in this output that comes out of the R generation. But let's now log on onto the OpenShift console. Okay, so I'm going to log in not as kubeadmin, but as the project administrator. So let me go ahead and do that. So I'll log in as myself. This is the username and password that I specified in that wizard earlier. Sure. It's in the developer perspective, but I actually want the admin perspective. All right. So this is what was created for me by the wizard. Okay. So inside of my OpenShift cluster, you can see that I already have a registry that is there for me. I can go ahead and begin using this registry. You can also see that there is a project that was created for me. So I'll go ahead and select that project. And you'll also see that there's an operator that was installed for me. So here's the Open Liberty operator. This is the operator that we will use in order to do deployments of Liberty applications into Azure Red Hat OpenShift. It's a nice UI. Again, it allows for a more abstracted way of doing deployments. But also, as you'll see in the YAML, it significantly reduces the complexity of the YAML as well. So it's basically as though OpenShift knows what Open Liberty is. So if you're going to look at the Open Liberty application, there isn't one right now. There's a number of other nice things that you can take a look at in the Azure Red Hat registry. Let's go ahead and take a look at some of those things. So you can take a look at the workloads. You can see what pods are deployed, and you can see there is no pods right now. There are no deployments. You can take a look at things like config maps. You can also take a look at what your networking services are. So right now there wouldn't be any. You can take a look at the ingresses and routes, and you can see there aren't any. So next step we need to do, and I have all of this scripted, so I'm going to cheat a little bit. This is not the right window. Let me see if I can get another window up. Okay, here we go. I actually have all of that. So I do have some of the scripted here, but I'm going to copy and paste from the script. But I will explain exactly what it is that I'm doing before I do these things. So before we do any of that, let's make sure that the application actually runs locally. Okay, so let's start from the Java EE and microprofile end of things and see what is going on there. So you're going to need to do this whenever you're doing cloud-based development, right? So you always start from a local setup. So that's what we'll do right now. So here's the application that I'm going to use. It's called Jakarta EE Cafe. You can find the source code for this. It is actually inside of the examples that we have documented for Liberty and ARO. So what I'm going to do is it's a very simple Java EE application. As you can see, it's just a CRUD application. As you'll see in a moment, the only dependency it has is on Jakarta EE, and that's about it. So it uses things like JaxRS, CDI, EJB, JPA, and so on. So let's go ahead and build this application. I'm going to just do a Maven build of this application. So I'll do a clean. Okay, then I'll go ahead and do an package or install. All right, so now I have my WAR file built. So you'll see that the output finally was just a WAR file. So here's my WAR file. I do have Liberty set up locally. Okay, so here's my Liberty setup. I'm going to run this application locally on Liberty to make sure that the application actually works. And normally this is what you would do in your local development when you're actually developing the application. So I'll say run on server. I'll pick Liberty as a runtime. And this application is actually talking to the database running on the cloud. Okay, so here's the application. I'll show you the application very, very quickly. Let me open it up in a real browser. So it's a simple CRUD application. I already entered in some data here. Let me go ahead and delete something, and I'll recreate it for you. Let's say so it's a very simple CRUD application, right? There's not a whole lot to it. There's actually a REST interface behind it as well. Let me show you the REST interface. Okay, so by default, it's doing XML output. Here's the XML output, and as you can see, it's showing me what's there. So the REST endpoint will also allow you to delete and add and whatnot. Actually, in the UI, it's a REST interface that I'm using behind the scenes. So that's about it in terms of just the Java EE portion of the application. So let me go ahead and shut down the application now. Stop. Okay, so the next step for me actually is to take this application and dockerize it. So put it in a Docker container. So that's what we're going to do, and we'll see how we do that next. So I'm going to ls here, and here's my application. I'm going to go into the Jakarta EE Cafe directory, and here's my POM file. I'm going to just do a build again just to make sure, and this time I'll do a package. We don't really need install in this case. All right, so now we are actually ready to take this application, which is a WAR file, and put it in a Docker container. So that's our next step. So let's go ahead and perform that step next. So I'll just copy and paste the commands that I already have scripted. It's going to make it a little bit easier for me. So first thing we'll do is go ahead and do a Docker build, and I'll show you the actual Docker file that we are using. So let's actually next take a look at that Docker file. Let me do a build first, and then I'll show you the Docker file. Never mind. So I'll paste the command here. So this is a very simple syntax. It's simply saying Docker build and give this image a name. So take this WAR file and make a Docker image out of it. I want the Docker image to be called Jakarta EE Cafe v1. Okay, v1 is a version, and the dot means that take a look at the current directory and take a look at the Docker file in the current directory and build the image. So let's go ahead and build the image here. All right, so the image is now built. Now let me show you the Docker file. So if I do an ls here, you'll see that there is a Docker file in this directory. So let's take a quick look at the Docker file to see how that looks like. So cat Docker file. Okay, and what happened here? Okay, so here's the Docker file. It's relatively simple. So let me highlight it so you can see it real quickly. So I kept this Docker file very, very simple. I started just from the Open Liberty image. So we're using not Webster Liberty in this case, but Open Liberty. And then I've copied over the Postgres jar file. So there, I'm connecting up to the Postgres database. So I need a Postgres jar file. So I'm copying that over into the resources directory within the image. I'm also copying over the server.xml. So I need some configuration. The primary bit of configuration here you'll see in a moment is enabling microprofile, because I'll show you microprofile in our next demo, as well as making use of the Postgres jar file to create a data source. And I'll show you that in just a moment also. And then finally, I'm just copying over the WAR file that I built. So let me show you the server.xml. Actually, it's going to be a little bit easier to show that in the browser. I think it'll render better. So if I go into the server directory and show you the server.xml file, this is how that looks like. And you'll notice that other than Java E8, I've also enabled microprofile health and microprofile open API. And I'll show you both of those things in just a moment. Rest of it is just simple setup for Liberty. But the most interesting thing here is setting up the database server. Okay, so as you can see, I'm taking the database server in from the information from the environment in the Docker image. So now that's basically what's in the Docker image. So now we're going to go ahead and try to run this application as a from Docker as opposed to locally. So let me go ahead and take my cheat sheet and run the application within Docker as opposed to the IDE. So I'll just take this command, I'll copy it, and I'll show you what this command is actually doing in the command line. All right, pasting it. So what we're doing here is this is a Docker run, meaning run the Docker image, and finally the Docker image that we're running is the one from Jakarta EE Cafe v1, the one we just built. Other than that, I am specifying that I want this application to be speaking on port 9080, so I can access it from my local browser. And then I'm specifying those environment variables that are being used in the server.xml in the command line here. So this is the connectivity information. And as you can see, I'm pointing to a database running on Azure, the one that I just showed you a little bit earlier. So let's go ahead and run this and see what happens. Okay, so the server is now up and running. Let me go ahead and open up the application on the browser once again. So I'll do localhost port 9080 Jakarta EE Cafe. So here's my application again, but there's a couple of differences. So first of all, I've enabled microprofile health. Okay, so now you can see that the status of the server is up and running, and I can even check for liveness, and I'll see similar information. And also I have the Open API UI actually enabled here as well. So I'll show you that. All right. So for example, I could do the same invocation that I showed you before, and here's a test to do that. But in this case, instead of XML, let's pick JSON and hit try it out, and you'll see the output from that here. So here's the output. Let me increase the font size once again. So you can see that the response body and the same bit of information that we are seeing before. So I've enabled both Open API and microprofile as well as microprofile health, which we will be using in the next step. Okay, so the next step for me is to go ahead and push this image onto the repository, and the repository I'll be using is the built-in OpenShift container registry. Remember that when we went into the OpenShift console, let's go ahead and use the OpenShift console again, and we go up to the very beginning here and go to projects. There is the OpenShift container registry, and the OpenShift container registry URL is actually available to me. So next I'm going to just push this image into the built-in registry. So let's go ahead and do that. So in order to do that, the first thing I need to do is tag the image properly. So I'll show you the syntax for that. Let's Control C out of here. We don't need that anymore. Okay, paste. All right, so here's the syntax for that. I'm saying Docker tag and tag the existing image that I just created with the appendix of the fully qualified registry name. So here's the default route OpenShift. So this is the OpenShift container registry. I'm also specifying the project name, so project B9, so on and so forth, a generated one that you also saw in the OpenShift console, and then finally the name of the image. So I'm going to just go ahead and enter that and tag this image. And then I'm ready to push this image into the repository. So in order to do a push, I first need to log on onto the repository. So I'm going to just issue this docker login command, which by the way is also output for you conveniently by the solution template. Okay, so now I'm logged onto the registry and I'm ready to push this image into the registry. So again, I'll show you the syntax for that. All right, so simply docker push and then specifying the whole name, the whole long name of the image. So let's go ahead and do the push. And so the image is now pushed and available in the Docker registry. Now I can go ahead and deploy the application using a ARO deployment descriptor. So let's take a look at the deployment descriptor that I'll be using for this. So this is where it is. All right, let me increase the font a little bit so you can see it a little bit more clearly. All right, here we go. All right. So first and foremost, we're using the OpenShift Liberty operator. So this is a reference to that operator. And as a result, you'll see that the rest of the YAML file is actually quite simple. So you have to specify a name of this deployment. I'm calling it Jakarta EE Cafe. You have to specify a namespace or project. That is a project that we have created beforehand. You have to specify how many replicas you want. We want 2 replicas of this application. You have to specify the application image, and that is the application image that we specified earlier. And it is resolving automatically to the default container registry for OpenShift. This is why this name can be actually very short. The pull policy is set to always. We are exposing this through a route. So a route will be automatically created for us. We are specifying the environment variables here. Again, the same type of environment variables that I had used in my command line from before, again pointing to the Azure Postgres database. And I'm also specifying a liveness probe and readiness probe in this case. And we are using those endpoints that we saw in action before. So it's health/ready and health/live running at port 9080. So this is our deployment descriptor. So let's go ahead and copy our deployment descriptor and use it to do a deployment. So I'll Control C this. Now we're going to go back to the OpenShift console. And now, by the way, you can do this through the OC command and through the command line if you like. But here I'm showing you the graphical way of doing it. So let's go ahead and select the project. Once we've selected the project, we'll go to the operators, and we see that there is the Open Liberty operator. I'm going to go to the Open Liberty application to do a deployment. And I'm going to say create Open Liberty application. So hitting create here. There's a form view and a YAML view. You can use a form view and you can specify all of the values here, but it's more limited. The YAML view will provide you a bit more flexibility. There is a default one created for you here. We're not going to use it. So we'll paste in our YAML values that we had from before. We can go to the form view to actually verify that things look okay. So there's a name, Jakarta EE Cafe. There's the application image name, again the name that's in the OpenShift container registry. Pull policy as always. We have set to 2 replicas, and we are exposing it. So a route is going to be created for us automatically. You'll see that in a moment. So we'll go ahead and hit create. Once we hit create, the deployment will actually start. So now let's go back to the workloads and look at pods. All right, so you can see now that there are pods being created. So the pods are already running. They're not ready yet though, because we have those readiness probes. So we have to wait for the readiness and liveness probes to finish. And we'll see in a moment that they are actually ready. And as you can see, they are now ready. You can actually take a look at each of these pods if you wanted to. So, for example, you can take a look at the logs that is generated by each of these pods. And at the very end, it will probably say, hey, the application is ready to run, or something like that. Right? Default server is ready to run a smarter planner. So this this endpoint is the pods are now up and running. If you go to deployments, you'll see that there is now a deployment. It's Jakarta EE Cafe is a deployment name. And if we go into the networking, we'll see there's an underlying service that was created for us. And there's also a route that is created for us as well. So we can go ahead and hit this route now. Right, and we hit we have two replicas. You saw the two instances in the console, and we hit one of the instances. So now let's take a look at the application running in the cloud. All right, so there's the application. It is successfully up and running on ARO at this moment. So there's a number of other very interesting things in ARO that you can take a look at. So there's a networking information that you can see that we've already seen. There is no ingress defined right now, but there is a route and there is a service. There is obviously the deployment information that I showed you before. You can even access each of these pods if you like. So if you go to the pods, for example, and come over here, you can open up a terminal, literally, and this will tell you this is the exact environment that is actually running locally on that pod. So it's pretty convenient in terms of being able to do any kind of debugging, or if you just want to do a one-off test, you can, for example, go into let's say cat or pwd, and where the root and so on. So basically, the full environment is available to you. You can also take a look at the logs as I showed you before. Above and beyond that, if you go into the home and look at the project, you'll also see interesting metrics in the OpenShift console as well. So you can see the memory being used as the two pods that we created. So a number of useful information in the OpenShift cluster. In order to do an undeployment, we can simply go to installed operators and simply do delete the OpenLiberty application, and the application will be undeployed. So let's go ahead and do that, and I'll just show you that. And if I go to the pods will be terminating. So very soon they'll be terminated, and there's no more pods. And I can redo the deployment real quick, just as quickly as before. If I try to access this, you'll see that the application is not available. So as you can see, it's pretty powerful stuff, very, very usable. The OpenLiberty, it allows you to be in a container-based environment relatively quickly. And it's all documented, it's all easy to go, and we've also even simplified all of that for you using the solution template, so that the getting started experience is super easy, and very easy for you to get started also. So I'll just show you some of the commands that I was using is actually here. So here's the login command. There is the tag command that I used. All of that is spit out. There's a push command that I used. Literally everything that I used in my script is actually output by the solution template as well. So I think that's all the time we have. I think we have just about 5 minutes. Let me stop sharing my screen and get back to the presentation. And if you have any questions, let me know, and we'll certainly do about 5 minutes of Q&A. So any questions out there?
Yeah, Reza, there is one question about how can we configure the deployment auto scaling in the OpenLiberty YAML?
So you define the scaling not in OpenLiberty, but you actually do it in the Liberty, rather the deployment descriptor for OpenShift. So you can say that I want auto scaling, or I don't want auto scaling, or I want maximum and minimum number of nodes, and so on. So by default, what happens is that the auto scaling is turned on. And the default number of pods is the number of replicas that you specify. So that is we specified two instances. Two instances is where things will get started. And if the demand rises above a certain default threshold, which you can also specify in the deployment descriptor, your node count will increase or maybe even decrease if there's a period of inactivity. So all of that is not in the Liberty settings. It's actually in the OpenShift operator settings instead.
Awesome, Reza. There are no more questions. There are greetings from Colombia, from Giovanni. Also, Carlos is saying hi. And well, Carlos Ella is remembering OpenShift and a comment about how is it that the that OpenShift is improved. I don't know. I think there are no more questions. I don't know. I think we can end the session for today. Thank you so much.
And hi back to everyone. And hopefully one of these days we can begin traveling again and seeing each other in person. And I get to visit Colombia and Peru and all of the wonderful people and places in South America. But yeah, I think that's about it. I really appreciate your time, and I'll see you maybe in about an hour.
Thank you, Reza. Bye, everyone.